वो ये देख लो. Okay. So good afternoon everybody, and I hope that all of you are safe and at home. As you know, in last live session come lecture 37 we have discussed that I told you already that we are almost finished with our this one syllabus, and we have already done revision. So before I take queries from you, so what I will do is that I will go through some of the usual queries which comes to the mind of every person who works on membrane related areas. We will go, I have some 10-15 something like that, I just wrote it, and yeah, around 18-19. So I bought it in a piece of paper. So I will just explain it. So please listen. So once that is over, so we will discuss if there are any queries from you. And one more thing, that you must have noticed that we have already re-evaluated your assignments. You can check that by going online, and still if you have any issue, please feel free to write to us, drop a mail, or to please write it in the post it in the discussion forum. So let us begin our discussion today. So the first question which comes to our mind is that what is the basic difference between a membrane and an ordinary filter? You know, if you go by IUPAC recommendations, so you will say that a membrane is something which is less than 0.2 micron sizes, the pore sizes, and anything more than 0.2 micron will come under standard filtration. Then another question which comes out to my mind is that about the molecular weight cutoff. Okay, this is very important, as we have discussed in detail in our this one, but somebody asks you a question in an interview. Let us say, please define what is molecular weight cutoff and what is its importance. How do you do that? How do you determine it? So you can take an example and tell that if you say that if the molecular weight cutoff is 400, let us say 400. Okay, then molecules of molecular weight which are greater than 400 will be totally rejected by the membrane. This is what is the definition. Now, it is a characterization property of the membrane. So, membrane experiments can be done at various solutes. So, you use different types of solutes of different molecular weights, and then you note down the observed retention, then you plot it. Okay, observed retention against the molecular weight, the log plot basically, and you get a S-shaped curve. So, the S-shape changes according to the molecular weight cutoff that is being determined by the membrane rejection. It can be a diffuse cutoff, it can be a sharp cutoff. These things we have discussed. Then another question is what is real retention and what is observed retention, right. So, real retention represents the membrane solute interaction and defines the selectivity of the membrane. So, which is defined by R equals to 1 minus Cp by Cm, and how much solute concentration in the permeate stream compared to the feed stream is determined by the observed retention. So, here the retention equals to R equals to 1 minus Cp by C naught, the original feed concentration. Okay. Then another question, when we obviously discussed RO, we have discussed this osmosis, and when we discussed reverse osmosis, what is osmotic pressure? Okay. These are very basic things I am telling you. These type of questions are usually being asked in interviews. Okay. If when you face interviews, and so osmotic pressure is a colligative property of a solute and can be realized in presence of a semi permeable barrier. Okay. So, and then what is the difference between osmosis and reverse osmosis? If somebody asks you, so what will be the answer? The answer will be that when the passage of solvent from low concentration to high concentration happens due to the concentration gradient, that is called osmosis, and anything that is reverse of this phenomena is reverse osmosis, and you will get and reverse osmosis will come into picture because of an applied pressure, and that pressure must be greater than the osmotic pressure. Okay. And we need to understand that reverse osmosis is happening against the natural gradient. So, that is why there is a need to apply a pressure which is more than the osmotic pressure. Okay. So, these are some of the basic things that all of you and must understand. And you remember there is something called a gel concentration, we note down by Cg. Okay. So, how do you find it? Okay. So, what you need to do is that you need to perform some experiments at various feed concentrations. So, the gel layer concentration is determined by extrapolating the best fit linear data. Okay. So, it is a linear fit that you will be doing, and permeate flux versus ln of C naught. C naught is the initial concentration in the feed where it cuts the x axis. Okay. So, this is how you find out the Cg. Then the next one is how membrane casting is done. This many people have asked me in mail. Sir, few questions are I have actually taken from few of your mails which you sent to me. Okay. So, how do I prepare a simple membrane by casting? This is one of the question which was posted by one of our this one candidate from one of the foreign countries. So, and how pore size can be controlled? It is very easy to do. Okay. So, first is that you know something, there is a polymer cast solution. So, you need to prepare the polymer cast solution. So, to do that, what you need to do is that you have to dissolve the polymer matrix in acetone. Okay. Why I am telling acetone? There are other things also. Acetone is not the only solvent, but acetone is most widely used solvent, and most of the labs, wet labs, you will find acetone in the labs. So, dissolve the polymer in the matrix in the acetone. The second step is that put solution in glass plate, okay, and make a thin film with another plate. So, basically you take a glass plate, very clean glass plate, pour the polymer cast solution over that, take another glass plate and then remove the excess whatever it is, just it is okay. So, just scrap it out whatever the excess that, okay, at what angle or what is the distance between the two glass plates, basically that will determine the thickness of the membrane. Then once it dried up, you put it in ice bath, okay, ice water bath. Then you can do for these are easy to do, that is what I am telling in the lab. You just need one polymer, you need an acetone, you need 2 glass plates and maybe an ice bath or something like that. You can easily do it in the lab. And then what you can do is that you can remove the solvent by heat treatment also, that is annealing. So, annealing is a metallurgical process, we have discussed it in detail, I am again not going to tell it. Okay. And the control of pore size in such a crude way of preparing a membrane, okay, how can I control the pore size for my lab scale experiments? So, I can do that by annealing, rate of heat transfer and duration of putting it in the ice water mixture. So, these will eventually determine the pore size. Okay. One more thing I forgot to tell you is that once you take it from the ice water bath, you can stretch it little like this. See the take the film. Okay, I can tell you that stretch it from both sides slowly, very slowly, from this side and this side, almost at equal pressure or equal velocity, you can say. Okay, so very little. Okay, not much. Not don't try to stretch it more, otherwise it will develop bigger cracks. Okay. Then again you go for annealing, whatever the loosed polymeric materials will be there in the pores, it will all come out, then you can go for another drying process, right. So, this is the easiest way to cast a membrane using a polymer in the labs. So, then we must understand that what are the most important properties of the membrane, any commercial membrane, we are talking about commercial membranes. Okay. First and foremost is high selectivity. Second is high permeability, right. Third is good mechanical and temperature or thermal stability, and fourth is chemical resistance, right. Membrane life is also very important, because you know that if the cell life of the membrane is less, then the cost to the company increases or cost for the process increases. So, the membrane should be reusable. Okay. Then let us move ahead, we can go take another similar type of query or question. Somebody asked what is the difference between extractive distillation and pervaporation. We discussed what is the difference between membrane distillation and pervaporation last class or last live session. So, extractive in distillation, what happens, the separation principle is based on VLE, the vapor liquid equilibrium, whereas in pervaporation the separation is based in the differences in solubility and diffusivity, that means the solution diffusion. Okay. and in the extractive distillation, the distillation characteristics is fixed by the VLE, vapor liquid equilibrium. In pervaporation, it is determined by the choice of the material, membrane material. Membrane plays a big role. Okay. So, another question is that if you have any query, you please post it. Once I wind up this, maybe another 10-15 minutes, then I will take up these queries. Okay. So, another question which comes to the mind or usually being asked in interviews is that what is the difference between membrane electrolysis and membrane electrodialysis? Okay. Electrolysis and electrodialysis, right. So, membrane electrolysis is a process where both electrode reactions, okay, that is the cathodic reaction, reduction as well as the anodic oxidation. Okay. In cathode reduction happens, in anode oxidation happens, are linked to the transport and transfer of charged ions. Okay. This is what is membrane electrolysis. So, the purpose of membrane in this electrolysis process is to separate the anode loop, okay, that is anolyte, from the cathode loop, that is catholyte, by a fluid in order to avoid unwanted secondary reactions, right. So, the membrane is playing that role, okay. So, as to combine the electrode reaction with a separation step or to isolate separately the products formed on the electrode. Now, you got it. So, the membrane is physically separating this catholyte and anolyte. So, what is electrodialysis? So, electrodialysis is a membrane based separation process where the ions are driven through an ion selective membrane. It can be a cation exchange membrane or cation transfer membrane, it can be an anion exchange membrane or anion transfer membrane, okay, under the influence of an electric field. So, in electrodialysis, so you must have two electrodes for one stack. Okay. So, two electrodes, in between there is a membrane stack. We can have more membrane stacks in between also, no problem. That is the usual feature of the electrodialysis, whereas in membrane electrolysis, so we can each compartment requires two electrodes. Okay. Right. So, you cannot have more membranes inside two electrodes just like electrodialysis. So, this is just the basic features or basic difference between these two processes. Now, then what is electrophoresis? Okay. This is also important. So, you must understand what is electrophoresis. So, electrophoresis is the movement of a particle or let us say any material attached to the surface of the particle, okay, relative to a stationary liquid under the influence of an applied electric field. So, what happens? One phase is suspended in another continuous phase, that is you can say from solid to liquid, and under an external electric field, suspended phase executes a motion which is known as the electrophoretic velocity or mobility, right. So, another question which comes related to this electrophoresis is that electroosmosis. Okay. You know osmosis, we understand what is reverse osmosis. Now, let us understand what is electroosmosis. Okay. So, the liquid or let us say an electrolyte solution moves past a charged surface, that is the surface of a capillary tube or through a porous plug under the influence of an electric field. So, this is what is electrophoresis or electroosmosis. So, electroosmosis is the complement of electrophoresis, that is why we are discussing it together. So, the pressure needed to be balanced the electroosmotic flow is known as electroosmotic pressure. Okay. So, another thing to note down regarding electroosmosis is that here the solid phase is stationary and the liquid phase is in motion under influence of the external electric field. Okay. So, another important question which usually people ask or comes to mind is that very simple thing, what is an asymmetric membrane and what is an composite membrane. Okay. So, we have discussed it many times during our composite membrane discussion or during our discussion of preparing asymmetric membranes. I am again repeating it. An asymmetric membrane, I am telling you the exact definition which is given by the IUPAC. Okay. Asymmetric membrane is the membrane that is constituted of two or more structural planes, okay, of non-identical morphologies. Please underline non-identical morphologies, usually prepared from the same polymer, okay, not necessary, but usually. And what is a composite membrane? So, composite membrane is also a form of asymmetric membrane. However, membrane having chemically or structurally distinct layers. Okay. So, this is what is a composite membrane. So, this is the basic difference between a asymmetric membrane and a composite membrane. And what is a dense membrane or a non-porous membrane? So, a non-porous membrane, okay, or dense membrane is which is used for your reverse osmosis, your gas separation, of course, then your pervaporation and all these processes. So, membrane with no detectable pores. So, we cannot detect any pores in the membrane. So, we can call it a dense membrane or a non-porous membrane. So, what is a homogeneous membrane? So, a homogeneous membrane is a membrane in which essentially that it has the same structural and transport properties. There are two things. First is the structural properties, morphological properties, and then the transport properties, okay, like flux, selectivity and all these things. So, through its thickness, thickness is most important. We have discussed it many times. More the thickness is playing an important role or providing a resistance. It is usually the practice that we should have less thin membranes for the better separation processes. Right. So, next is we have discussed this, again I am telling you what is membrane distillation. So, it is a process in which the liquid and gas phases are separated by a porous membrane. Please note down porous membrane, which is not so in pervaporation. And second thing is that pores are not wetted by the liquid phase. Okay, right. So, I told you na last time also a membrane distillation, porous membrane, there is we are creating vapor or lower pressure here. So, the pore is the membrane is a hydrophobic membrane, hydrophobic porous membrane. Okay. So, due to hydrophobicity, the liquid is not able to wet the membrane pores. So, there is a distinction, clear distinction of a separation of two phases, one is a vapor phase, one is the liquid phase or the feed phase on the membrane surface, which is not so in pervaporation. In pervaporation, the feed and retentate both are liquid, which is wetting the membrane. So, they are trying to get into the membrane, then diffuse solubility and diffusivity, then going through the permeate. The permeate itself is getting vaporized, right, that is what is in pervaporation. Another important thing is that what is bubble point. You know bubble point we have discussed during the microfiltration membrane characterization. Okay. So, what is bubble point? So, bubble point is the pressure at which the bubbles first appear on the surface of the membrane. This is very important. The bubbles first appear, underline first, okay, appear on the surface of the immersed porous membrane as the gas pressure is applied from the other surface, from the below of the or the downstream side of the membrane or the back side of the membrane. Then what is solution diffusion? You know solution diffusion also called as sorption diffusion. So, it is a molecular scale process in which penetration the penetrant or the solute, okay, solvent whatever it is sorbed on the membrane surface or the upstream membrane surface from the external feed phase, moves by molecular diffusion in the membrane to the downstream side by concentration gradient, of course, okay, and leaves into the external phase either in gas form, vapor phase, vapor form or liquid phase, okay, at the downstream side. Another just a simple thing, what is brackish water? What is sea water? What is brackish water? Brackish water is not exactly the sea water. What is brackish water? Okay. So, brackish water is usually the term which indicates that water having a total dissolved solids TDS, the total dissolved solids content that is much less than that of the sea water, but above much higher than that of the potable water. So, you can say the TDS of the water which lies between the potable water and the sea water much more than the potable water and much less than that of the sea water. Okay. So, with this I stop. This is what I wanted to tell you today and wanted to discuss you, because these are the some of the questions which usually being asked in the interviews. Few 7-8 questions are the queries by few of you through email. So, I thought we will discuss this. I hope you have understood whatever it is, and now I will take up any queries if you have. Okay. कुछ है? Okay. Okay, there is one query, even I think all of you can see that. How can we select the membrane for membrane bioreactor to separate conversion of fumaric to lactic acid based on mechanical strength or chemical nature of the material? Both plays an important role. Mechanical strength is less important in this, because we are not playing putting much pressure when we talk about a membrane reactor or bioreactor. Okay. So, the membrane material should be non-corrosive to your fumaric acid as well as lactic acid and other solvents which are present. Mostly you can go for ultrafiltration type of membranes, and what is the cutoff size of membrane, that has to be decided based upon so many things. It is not about only lactic acid and fumaric acid, it has to be decided upon what are the other components which are present on the solvent or the solution. Okay. Just waiting for a few more minutes. I am done with whatever I wanted to tell you, and took up one query. If there is any query, please post it. And as you know that today is the final Tata from me. So, no more live sessions and no more lectures, no more assignments. We are done with everything. So, we are waiting for the lockdown to be lifted in India, so that we can go ahead with our final examination, which was originally scheduled on 25th of April. Now, it has been postponed indefinitely. Hopefully, if things go smooth, we expect that in the month of May, last week of May or something, or maybe in the month of June, sometime we can have it. It depends on so many other things. It is not that lockdown has been lifted, then we can go for it. The usual movement, traffic movement should be allowed. Second thing, this that our partner who is one of the big industry giant, who is our partner to conduct this examination, they must also be ready to provide the infra facilities to conduct the examination. And we should, there are so many other things, basically we will come up with them. So, keep on checking at least every 2 days, 3 days, please keep on checking the membrane technology home page in the SWAYAM portal, log in and check if there is any announcement. Okay. So, keep on checking the announcement for the final exam. So, students, so finally I am signing up. So, as I told you, no more interaction with there. However, you can please post your queries in the discussion forum. Please do not send me an email, I will not take up the emails again. So, please post it in the discussion forum, either me or my TAs or our team will reply you at the earliest, and keep on checking the portal for the announcement of the exam. So, thank you very much, and I am grateful to all of you, those who have registered this course for this course and have listened to my lectures very patiently. I hope you must have enjoyed it. So, all the best for your final exam, and thank you very much. Stay safe and stay home. Thank you.